In this video, we look at AWS Cloud interview questions and answers. Throughout this video, we will be covering frequently asked interview questions that I got most in my DevOps interviews, along with many scenario-based questions, and I will provide you with practical solutions doing it on the console and also helping you on how to answer them in your DevOps interviews. So let's get started. Alright, so I'm here on my computer screen and I'm so sorry if I look tired. It's because I am not feeling well. But here we are with AWS Interview Questions and Answers video. In this document, I have noted down all the most asked interview questions along with their answers, and I will also show you how to solve them practically on the console so you can better answer them. So now, without wasting any time, let's start with the video. Whenever you sit for any technical interview, the first question that you usually get is, tell me about your experience and the past projects that you have worked on. This is very common, but it's very important for you to answer it properly because this will tell the interviewer how technical you are. So mention your projects and the problems you might have faced. I've also answered this question very properly in the DevOps Interview Questions and Answers video, where we've covered self-related questions on Linux, networking, Terraform, and a lot more. So I highly recommend you checking that video if you have an interview very soon. But in this video, we are going to be covering questions related to AWS services like VPC, Lambda, S3, EC2, CICD Pipeline, and a lot more. So let's start with the first question, which is to explain the steps to set up a secure VPC with subnets and everything. This is actually a very tricky question to understand if you have knowledge on AWS or not. This question I have received a lot of times, and I also ask this question whenever I take interviews because this gives a general idea of if the candidate actually has hands-on knowledge on AWS. So what are the steps to set up secure VPC? To create a VPC, you need to go to the VPC service, which is Virtual Private Cloud. You first start with creating a VPC where you select the CIDR range and the name of the VPC. Once the VPC is created, you then create subnets, which can be public subnets and private subnets, depending on your use cases. So you first go ahead and click on Create VPC. In the VPC, you need to set the CIDR range. You need to set the configuration like enabling DNS host names or resolution. Then you select how many subnets you want in what AZ. And you also need to create route tables, which will define that the public subnet should talk to Internet Gateway, whereas private subnet should talk to NAT Gateway. So you can also create Internet Gateway and NAT Gateway. Here are the steps. You first create a VPC, then you create subnets, then you configure route table. NACLs or network access control list can be created where you can manage inbound and outbound traffic coming inside or going outside your VPC. Similarly, you can also create security groups if you have any servers and you want to manage them. Along with that, you need to add Internet Gateway. Optionally, you can have NAT Gateway or NAT instances to give internet accesses to your private subnets. And if you want to monitor traffic, you can enable VPC logs or monitor it through CloudWatch. This is how you should be answering this particular question. Moving on. The next question is, explain what this IAM policy does. IAM in AWS stands for Identity and Access Management, which lets you create users, groups, and roles. And these users, groups, and roles are attached a policy. Policy is a JSON document like this, which defines what permissions should be given to users, groups, or roles. In this question, we have a simple policy, and the interviewer is asking you to explain what this IAM policy does. So in this IAM policy, we have two statements. You can see this is one statement here, and this is second statement here. If you look at the policy properly, there are three things: effect, action, and resource. So effect is allow, which means it is allowing something. So it is allowing you to list bucket and also the items inside the bucket only for this particular bucket, which is company data. And the second part of the policy is saying allow running task on this particular task definition only if you have ARN equals to this. ARN in AWS stands for Amazon Resource Name, and it is given to every particular identity in AWS. So the second part of the policy is saying you are allowed to run tasks on this particular task definition, which have a prefix update tables, only if you have ARN this. And if you don't understand, you can go ahead and read this by pausing the video. Moving on, let's go to the next question. The next question is, how do you secure sensitive information such as API keys, passwords, and other credentials in CICD pipeline on AWS? So on AWS, you can create CICD pipelines using tools, using services like Code Pipeline, Code Build, Code Commit. And it is very important for you to have a secure pipeline where you don't put your passwords, your API keys inside the pipeline hard-coded. So what you can do, being a good DevOps engineer, you should be storing your API keys or passwords or any secrets in tools or services like Secrets Manager. So using Secrets Manager, you can easily create secrets, you can rotate them or also give access. So you should always store your passwords or your database credentials or anything inside Secrets Manager. Once you put your passwords here, you should be giving access to CI/CD services using IAM role. So this is how you can secure your APIs or passwords rather than hard coding them. You can look at the answer here. So you can use AWS Secrets Manager or Parameter Store to store your secrets like APIs, keys, passwords, and then use IAM roles for CI/CD services so they can access these secrets present inside Secrets Manager. You should always rotate secrets. You can make sure that the secrets are changed every 10 days or 30 days according to you. You should also encrypt data using KMS keys. In AWS, you have KMS or Key Management System service that lets you encrypt data at rest, also in transit. And you should also enable audit access such that if anyone is changing secrets, you should be notified. You can do that using CloudTrail, which is a service that lets you audit or also note down what changes have been made by which particular user. So this is how you can secure sensitive information rather than hard coding them in the code or in your pipeline script. Moving on, the next question is, name some AWS services which are not region specific. So if you look at AWS services here, every service has a region here. So we can select what region do you want to work on. So I am right now in North Virginia for the AWS Secrets Manager. So anything I create inside this region will only be present here. But there are few services which are not region scoped and they are global, such as IAM. So IAM, you do not have option to select the region. Right now you can see it's global and everything is blurred out. Similar to IAM, you also have Amazon Route 53 and AWS CloudFront, which are some examples of AWS services that are not region specific. They are global service. The next question is, describe the key difference between Amazon EC2 and AWS Lambda. When would you choose one over the other for a specific task? So if you go to AWS dashboard and select the compute section, you will see EC2 and Lambda are both compute services in AWS. EC2 lets you create virtual servers in the cloud, whereas Lambda lets you run code without thinking about servers. So this is a serverless service where you don't need to create any servers. So you will be using EC2 whenever you want to have a server created. For example, maybe setting up your website or setting up a database server, whereas you will be using Lambda whenever you want to execute something for a short duration without managing any server. Some of the examples could be here. So if you see, Amazon EC2 provides virtual servers that you can manage, while AWS Lambda runs code in response to events and it scales automatically. Choose EC2 for long-running tasks or when you need more control over the environment, for example, hosting a website or running a database server. Whereas Lambda can be used whenever you want to have event-driven, short-lived tasks with automatic scaling. Example could be, you want to update a record in a database whenever you upload something on S3. So when you upload something on S3, you can enable S3 event notification, which will run a Lambda and put the records in DynamoDB or any database. So this could be managed using Lambda. For example, processing event-driven actions such as file uploads, database updates, or API requests. Here is a table that will provide you more information on difference between EC2 and Lambda and when to use it. The next question is on Cloudformation. The Cloudformation template has an error that you have omitted. What could happen as a result of the error and how would you correct it? So Cloudformation in AWS is a service that lets you create resources like EC2, S3, RDS, and many others by defining them in the code. So it's an infrastructure as code service. What will happen if you made an error in the template and then you commit it? If you made an error and you commit it, either it will not run. If it is running, it will not create the resources carefully and there might be a security issue. So how can you solve this? You can solve this following all the steps here. So you should first identify what the error is by running AWS Cloudformation describe command. So you can check where the error is. Once you find the error, you can change it and then you can validate your template by running AWS Cloudformation validate command. Next, if you want to check what is going to happen after you made the change, you can run the change sets command to preview what changes is going to happen. And once everything is okay, you can go ahead and deploy your updated template by running AWS Cloudformation deploy. So this is very important to know because many companies use Cloudformation to deploy resources on AWS. I have many clients who use Cloudformation, although I have told them that Terraform is better, but they have all the resources on AWS, so they choose to use Cloudformation. So you should be having knowledge of Cloudformation whenever sitting for AWS interviews. Moving on, the next question is, in VPC with private and public subnets, database server should ideally be launched into which subnet? This is actually a very easy question, but you should be answering this carefully and also stating why you're going to deploy your database in either private or public. So database server should always be deployed in private subnets because private subnets don't have internet access. So users on the internet cannot directly talk to your databases in private subnet. You will have to use NAT gateways or NAT instances. So database server should ideally be launched into private subnets. This ensures enhanced security by restricting direct access from the internet and also allows tighter control over the network access using security measures like security group or NACS. So here is a diagram which explains that RDS is in private subnet and you can access it through Bastion host or NAT instances here. Moving on, the next question is, how do you choose the right database service in AWS for a specific application's requirement? Tell a little bit more about your experience. So this is also a scenario-based question or maybe your past experience question. So how would you choose the right database service in AWS? So in AWS, there are many different services just for databases. You could see you have DocumentDB, DynamoDB, Elastic Cache, and all those here. RDS is Managed Relational Database Service. So first thing is to check what is your application's requirement. What kind of data is your application holding? If your application is holding relational kind of data or SQL data, you can go with RDS that lets you create SQL databases like MySQL, PostgreSQL, IBM database and others. So you can use RDS whenever you have a relational database, relational data. Similarly, if you have a non-relational kind of data which you need to scale automatically, you should go with DynamoDB, which is a NoSQL database, and it can scale up very easily. So you can see here, RDS is ideal for applications that require traditional relational database and for standard SQL support, transaction, and complex queries. Whereas DynamoDB suits application needing a highly scalable NoSQL database with fast, predictable performance at any scale. Then you have Amazon Redshift. When you have huge amount of data and you want to run complex queries on it, you can go with Amazon Redshift. Similarly, there are also other services or other database services like Elastic Cache, which is an in-memory database. You have key spaces which is similar to Cassandra, DocumentDB similar to MongoDB, and so on. So this is how you can answer it. If the application requires SQL database, you can go with RDS. If it requires non-SQL database, you can go and use DynamoDB, or you can use Redshift when you have huge amount of data. With that being said, you can also use EC2 instances to install any kind of data. These are all AWS managed service, so you're using this. But you can also use EC2 to install MySQL or Postgres, MongoDB, any kind of database you want. The next question is, explain the concept of autoscaling and how it can be implemented in AWS to handle fluctuating workloads. So autoscaling in AWS means automatically scaling up your instances or your servers, or also deleting them whenever you don't need it. AWS has autoscaling feature, and you can use this whenever you have increasing traffic or unpredictable workloads. Using AWS autoscaling, you can easily create or delete servers when you don't need them. You can see autoscaling is here, and autoscaling helps maintain the availability of your applications. In this, you can set up a parameter, let's say 50% of traffic. If my server has 50% of traffic, create another server. If it is less than 20%, delete the server, something like this. So autoscaling automatically adjusts the number of instances in a group based on demand. It can be implemented in AWS using services like Autoscaling Group, which dynamically adjusts capacity to maintain performance and reduce cost. You can see a diagram here which explains how autoscaling works. So you can have desired capacity and you can set the maximum size or minimum size depending on how much servers you want all the time. Let's move to the next question. Explain, can you vertically scale an Amazon instance? How? So scalability are of two types, vertical scaling and horizontal scaling. Vertical scaling means increasing the power, which is CPU and memory. Horizontal scaling means increasing the number of servers. So in this question, it is asking, can you vertically scale an Amazon instance? If yes, how? Let me show you how you can do that. So if you go to instances here, in the instances right now, I have one instance which is Docker and it is in stop state. Whenever you want to vertically scale up, make sure your instances are in stop state, and you can do that by selecting it, going to the instance tab and stopping it. My instance is already in stop state. So I'm going to click on actions here and I'm going to click on instance settings. In here you have change instance type. Once I click on this, I can choose, right now it is T2 medium, I can make it T2 large, which is vertically scaling from T2 medium to T2 large. T2 medium has 4 GB RAM, T2 large will have 8 GB RAM, which means I am increasing the power. So let me show you how to do that. So I'm going to select T2 large now and click on apply, and this will change my server from T2 medium to T2 large. So this is how you can vertically scale. Next, can a connection be made between a company's data center and Amazon Cloud? If yes, how? So this is very important question for companies who are migrating. You should be knowing how to use different services to connect the on-premises data center to AWS accounts. So you can do that using two very popular services. One is the direct connect option. So using direct connect, you can connect your AWS accounts with your on-premises data center on a private network which is not connected to the internet. So AWS Direct Connect lets you establish a dedicated network connection to AWS, a dedicated network connection, which means it is going to be private. Similar to this, you have VPN or virtual private network, which also provides a connection between your AWS account and your data center, but securely on the internet. So you can use VPNs as well, which is here. Other use cases could be if you want to share your data from one place from on-premises to your AWS account. You can also use AWS Storage Gateway, where you can connect your data center with your AWS account. So here is the answer. Yes, a connection can be made using Direct Connect, which is high bandwidth link for private connection, and virtual private network, which is encrypted connection over the internet. So this is how you can create connection, and it is very important for you to know, because companies are looking for people who know how to migrate stuff from on-premises to the cloud, because this is very common. Many companies have their stuff on AWS as well as on-premises data center, which is also known as hybrid cloud architecture. Next, the question is, explain different AWS services to manage cost. Cost management is very, very important. No company wants to spend more than what they should be spending. So you need to know different AWS services on how to manage cost. You can check that out from the Cloud Financial Management service here. And these are some of the services that you can use. Inside billing and cost management, there are few very important services that can help you manage cost. You can see here, the first is Cost Explorer, which provides you with information on how you are spending, how much is going to be the forecast, how much you'll be spending in the future. And you can also change dimensions and dates according to your use case. This will provide you how you are using stuff, and then you can change or delete services if you don't need them. Similar to this is budgets. You can create budgets to define how much you want to spend rather than spending a lot of money. So using budgets, you can select how much you want to spend, and whenever you spend more than that, you get a notification on your mail. So you can see I've created budgets which are exceeded, and I get mails on my email ID. Similar to this, there are also other services like Trusted Advisor, which will provide you with recommendations on things you should be doing to save cost. You also have cost and usage reports that we have seen already. And you can use AWS Savings Plan to save money whenever you have a dedicated or a committed usage. Example could be using EC2 instances, reserved instances, which will let you save money if you use that instance for 1 year or for 3 years. Moving on, the next question is, what is the difference between NAT Gateway and NAT instances? Why do you use them? So NAT instances was something which was popular before NAT Gateway came into AWS. But NAT Gateway and NAT instances are very same. They both do the same thing, which is to provide internet access to servers in private subnet. But NAT Gateway is AWS managed service. You can go ahead and create NAT Gateway, whereas NAT instances are on EC2 machines. You need to install and configure them properly. So NAT Gateway is managed by AWS. It is high performance and availability, no administration required. Whereas NAT instances are user managed EC2 instances, requires manual scaling and administration, less scalable compared to NAT Gateway. The use cases both enable outbound internet access for resources in private subnet, enhance security, facilitate compliance, and you also have a diagram or a table here that explains the difference between NAT Gateway and NAT instance. You can see NAT Gateway has bandwidth up to 45 GB per second, whereas bandwidth of NAT instance depends on what is the instance size. If it is T2 large, it will be good. If it is T2X large, it will be more. So these are all the differences between NAT Gateway and NAT instances. Next, the question is, what are different ways to access AWS services? We have seen the first way is to use the management console. Using management console, I can create services, I can delete services. Another way is using AWS CLI, which is a command line tool. So you can use AWS to do anything you want. Let's say if you want to do anything in S3, you can find, if I do AWS S3 LS, I can get the list of buckets in my account. So AWS CLI is another way to access AWS services. Similar to this is SDKs or software development kits. So if you know Python, you can also access or create AWS services using Python. And the next, so here is the answer. You can use AWS console, which is a web-based interface, and you can click on things to create it. You can also use AWS CLI, command line tool. You can use AWS SDKs to create stuff using your own favorite programming language. And the last one is AWS Cloudformation, which is infrastructure as code tool. Terraform also is an infrastructure as code tool, and it also falls in the same category. So no need to mention here, but you can also tell that in your interviews if you want to. So these are different ways for you to access AWS services. Moving on, the next question is, what are different types of load balancers and when to use them? In AWS, there are 4 different types of load balancer as of now. If you want to see it, you can go to the EC2. Below you will see load balancers. Load balancers are used to manage traffic on multiple servers. Right now, AWS provides you with 1, 2, 3, and the 4th one, which is the classic load balancer, previous generation. Application load balancer can be used whenever you want to have HTTP and HTTPS traffic. Similarly, if you're managing TCP, UDP traffic and you want to have a highly performant, very fast connection, you can go with network load balancer. Lastly, gateway load balancer can be used whenever you want to connect your on-premises with your AWS accounts, or whenever you want to use third-party security appliances, you can go with gateway load balancer. So here is the explanation, and you can read through it to understand when to use which load balancer. Moving on, the next question is, how do you allow or restrict access to AWS services? We all know the first thing that comes in my mind when I read this question is IAM. I can create IAM users, I can give them policies to define what users should be doing. So I can restrict access or allow access using IAM. Similar to IAM, you also have resource policies. So in services like S3 bucket, you can select who can access this bucket, or who has permission to access it by attaching a bucket policy. So if I go to this bucket and click on permissions here, I have option to attach a bucket policy. Right now it does not have it, but this is something you can attach to allow or restrict access to this particular bucket. Next is network access control list. This is something on subnet level. You can define which traffic can come inside or go outside the subnet. Similarly, you have security group on instance level. You can define which traffic should come in and outside the server or the instances. Next, you have SCPs or service control policies. When you have multiple AWS accounts in your organization, you can define or allow or restrict access using SCPs or service control policies. You also have VPC endpoints to privately connect to AWS services like S3 using endpoints rather than using the internet, which is to avoid public IPs. So these are different services or different ways to allow or restrict access to AWS services. Moving on, the next question is, describe the advantages and disadvantages of using AWS RDS compared to managing your databases on EC2 instances. So we already know you can either create database directly using RDS, which is a managed service, or you can also create or install your database on EC2 instance. What is the advantage and disadvantage of doing it? When you use RDS to set up your database, it's all managed by AWS, so you don't need to install anything. You don't need to create backups, because you can automatically create backups using snapshots or automated backups in RDS. You also don't need to patch or do anything related to security, because it's all managed by AWS. And this is the benefit when you use RDS. Whereas if you use EC2, you have to manually install everything. You have to configure it. You have to do everything. But the advantage of setting up your database on EC2 is you get more power, or you get more administration access. You can go inside the server and change anything you want. Whereas in RDS, you cannot access it to the server. You cannot change anything if you want. So this is the difference. Advantages of RDS includes managed backups, automated patching and scaling. Disadvantages is using less control over the database compared to managing it on EC2 instance. So this is the difference, and this is the advantage or disadvantage. Moving on, the next question is, what is the relationship between instance and an AMI? So instance in AWS is known as server. We call servers as instances in AWS, and AMI stands for Amazon Machine Image. So when you create instance, you need to select the AMI. AMIs are of different types. So AMIs let you decide which operating system you want to use. You can see AMI here, Amazon Machine Image. And when you create a server, you select if you want to use Amazon Linux AMI, or Mac OS AMI, or Ubuntu AMI, or Windows AMI. But you can also create backups of your servers. When you create a backup of your server, which means you are creating an AMI. So let me show you an example. So right now I have Docker and I want to create a backup. Creating a backup means creating an image. So I go to images and template. I click on create image. Once I click on create image, it lets me put the information. So let's say my image. And I'm going to click on image, create here. And you can see it's also backing up my storage, which is attached to it. And when I click on create image here, it creates an AMI and I get this ID here. This is how I can create backups. So instance is a server and AMI is its backup. So an instance is running virtual machine, while an AMI is a template used to create instances and instances are launched from EMS. So I can just go ahead and select this image that I created, and I can also create a server out of it. Moving on, the next question is, what are different launch type and when to use them? So in AWS, you can launch your servers using different launch types like reserved instances, spot request, dedicated host. And so you can select your preferred launch type depending on your use case. If you have a server which you're going to be using for next 3 years or next 1 year, you can go with reserved instances that will provide you with discounts. If you want to have a server where you need to attach your own licenses and nothing related to AWS, you can go with dedicated host or dedicated instances. Similarly, if you want a server for a short period of time, which is okay if it got deleted, you can go with spot request. And I try to explain this very easily in this video, so you can go check it out. Next question is, can you describe the process of setting up a CI/CD pipeline in AWS using code pipeline and code build? So in AWS, we know different services that can help you create CI/CD pipeline. You can use code pipeline to set up an automated CI/CD pipeline, which includes stages like source, build, test, and deploy. So using code pipeline, you can create automated pipeline. Using code build, you can integrate build stage and test stage. And using code deploy, you can deploy it either on EC2, EKS, ECS, wherever you want to do it. So the process involves configuring a pipeline in code pipeline, defining stages like source, build, test, and deploy using all the different services that we have seen here. So this is the place where you can define the source. This is where you can build it. This is where you can deploy it. So this is how you can create or set up a CI/CD pipeline. The next question is, your application stores sensitive customer data in an AWS RDS database. How would you ensure the security and compliance of this data? So according to this question, we have an RDS database, and inside that RDS database, some data is present, which is very critical, and you want to make sure that it is secured. So you can make sure that the data is secured using different things like encryption. You can encrypt your data inside database using KMS. KMS, as we know, stands for Key Management System. That can secure your data using encryption keys. Similar to this, you can also use security groups on your RDS databases by defining who can access it or what traffic should come in or go out. So ensure encryption at rest in transit. Implement access control using IAM. This is also you can do. You can set up IAM rules or IAM policies to define who can access the database. Regularly audit database activity and comply with relevant regulations such as GDPR or HIPAA. So this is how you can secure your data inside RDS database. Moving on, the next question is, your team is adopting Docker for containerization. How would you deploy and manage Docker containers on AWS? So Docker is a service that lets you containerize your application. And let's say a company is moving from monolith to microservices using Docker. How can they use AWS services? So the first way is to install Docker on EC2 servers and then containerize your application and deploy it there. But AWS also has many other containerization services that you can see here. So you have ECS and EKS. ECS lets you deploy your containers using EC2 servers or Fargate. But you can also use EKS, which lets you deploy your containers on Kubernetes cluster. You also have ECR, where you can store your Docker images similar to Docker Hub. So deploy Docker containers using Amazon ECS or EKS. These services provide managed container orchestration, scaling, and integration with other AWS services. Next is, your company wants to migrate its on-premise infrastructure to AWS for cost saving and scalability. What steps would you take to plan and execute this migration? This is very, very important again, because many companies are actually migrating their stuff from on-premises to AWS. So how can you solve this, or how can you migrate your data? First thing is to check what do you have on-premises, what are different services that you want to migrate. Once you know what has to be migrated, select the migrating strategy, which are of different types like lift and shift, refactor, and re-architecting. Let's say you have a legacy application written in Java or C++, but now you want to deploy that on cloud. Maybe if you want to use new stack using Golang or Python, you will have to recreate everything. So you need to see if you want to just lift and shift it here, if you want to create it from scratch. So you need to select what migration strategy it will be required. Then you will estimate the cost using AWS pricing calculator. You can see how much cost is going to come if I migrate my stuff on AWS. Once you know the cost, you can then plan for migration, test it. If everything works okay, then you can migrate without downtime or with less downtime. So this is how you can migrate. You first check what is there, you then select the strategy, you then check the cost, plan it, and then you migrate it. Moving on, the next question is, describe how AWS IAM is used to manage permissions and access control in AWS environments. This we have already known. AWS IAM is used to create users for physical users, groups for group of users, roles for AWS services, and then you can attach policies on them to decide what they can do or what they cannot do. So IAM allows you to create and manage users, groups, and roles to control access to AWS resources. You can define policies that specify the permissions user have, ensuring least privilege principle. Least privilege principle means giving them only what is required, not extra. So this is how you can use IAM to manage permissions and access control in AWS. The next question is, describe how you would set up an automated testing process within your CI/CD pipeline on AWS. Whenever we create a CI/CD pipeline, we need to have tests to make sure that we follow the DevSecOps approach. So we should always add tests to make sure that our code is proper and it should go and work properly in the production. So how can you add automated testing process when you have CI/CD pipeline on AWS? So we know to create CI/CD pipeline, we have different services like code pipeline, code build that we have already seen so far. So to integrate test, you can do that in the build stage using code build here. But before you integrate it, you need to write the test cases. So you need to first select what test cases you want to write and what frameworks do you want to select. So you can either select JUnit or Selenium, and then you can write down the test cases, put them along with your code, and then use services like code build to integrate it. So choose the testing tools, first select what framework you want to use, then write the test, which could be unit test, integration test, end-to-end test, and put them alongside with your code. So keep test code in the same repository. Use AWS code pipeline to create and automate pipeline stages here, and then integrate testing tools like code build or Jenkins to execute the test whenever the pipeline is running. You can also store this test in S3 buckets, so store test artifacts or logs in Amazon S3 for reference. Use CloudWatch to monitor it, set up notifications. If anything is wrong, you can set up notification and then check it or change it, and then continuously improvement, regularly review and enhance testing process. This is how you can integrate testing process in your CI/CD pipeline. Very, very important, and most probably you will get this question whenever you apply for senior level interviews. Moving on, the next question is, explain the process of rolling back a failed deployment in AWS. What do you mean by rolling back? Let's say you have a deployment which has caused some issues and it is not working as you want. So how do you roll back to previous to make sure that the things are working all right? So first thing we will do is stop the deployment because it is not working fine. Then check what was the issue. Stop the deployment, revert it back to the previous version where everything was working fine. Check what was the issue, troubleshoot it, and then if everything is working fine, then you can upload it or then you can update it. So identify failure, monitor the deployment process to pinpoint what is the issue, halt any ongoing deployment to prevent further changes, investigate the cause by analyzing logs and errors to understand what caused the failing of the deployment, create a plan to revert back changes that were made during the failed deployment, verify if everything is working fine in the previous version. You can talk to your customers and make sure that everything is okay at their end as well, and then create a post-mortem analysis or root cause analysis to learn why this issue was caused and how can you solve it. So this was the end of our AWS interview questions and answers video. I hope this video was helpful and it will help you for your AWS interviews. If you want me to share this document with you, do let me know in the comment section, and also let me know if you want me to cover more such interview questions on Terraform, Kubernetes. Let me know in the comment section. I hope this video was informative. Thank you and best of luck for your interviews.